Hey, I'm Adam James, and did you know that I have a Twitch channel on which I do closure programming live, and I work on a few things, usually SVG, 2D design work, and also OpenSCAD and FreeCAD, 3D programmatic CAD. A lot of the videos on my YouTube channel are inspired by the work I'm doing on Twitch, and they're highly related platforms that I do my closure content on. And this particular video I'm really happy to show. It's the first, it's various clips from the first 100 VODs that I managed to do. And I did not manually edit this. What I did is write a Babashka closure script that used YouTube DL to automatically take clips with timestamps and apply some animated titles over it, and I'm extremely happy with the result. If you look here, I just have the clips listed in an Eden file, and all of the work is done by my computer for me, and I think that's super cool. As a first result, I'm really happy with this. There's additional animation work I want to do. There's more cleanup and sanity checks that I want to run into it, but I'm super happy that this worked at all, and I hope you enjoy the video. And before I show the clips, did you know that I also have a Patreon? You can check it out, patreon.com/Adam_James. I'm not saying you have to support me, but I am saying that you can. And with more support, I can actually start to improve the quality of the content I put on the channel. I can improve the frequency at which I make videos. So if any of that's interesting to you, consider becoming a patron. That would mean a lot to me, and it would really help out the growth of this channel. So give it a look, check it out. In the meantime, enjoy these clips. Map, apply, sphere A, over the map, which is grid. So that's a list of points. It should be 3D points, and that should work. Let's see what happens. Let's see what happens when I refresh the page. Oh, it'll have to recalculate some things. May have frozen that for a moment there, but it should work. So it's going to be a huge, oh wow, cool. Okay, so it does work. That's pretty fun. That's cool. Okay, so that's obviously not a brilliant way to make point sets, right? So I do want to figure out like the proper way to do it, but that looks pretty cool, if I do say so myself. And let's actually make this oh hey, yeah, that does work. Okay, so I just had values that were way crazy. This looks ridiculous in the best way. Oh, that's pretty weird. That's cool, I like that. Okay, so that is a torus and it is working. Let's see if that works. It should give us a random color. It does indeed. That looks hideous. I love it. That might work. It does. Okay, that looks way weird, but that looks really cool. So what I just did here, repeatedly rand will repeatedly generate a float value between 0 and 1. It'll repeatedly run the function rand, which generates a single value between 0 and 1. If you run it repeatedly, you'll keep getting an infinite sequence of random float numbers. And if you just take 200 of those and partition them by 2, that gives you 100 unique points in a random grid, and then you can use those points and run it through the triangulation, the Delaunay triangulation, to get triangles from those points, and then you map that 2D triangulation over the sphere, then you get this. And then for each of those triangles, you just run this little thing here. So you get the center point, you get the, and then you just create the animation with those various string types. But for a moment on identity here, I have some thoughts related to this now. Many people that I've encountered in my life identify rather strongly with school and their work. And so I do my best to not do that myself, but it's tricky, you know. Sometimes you do feel like what you do defines your identity or something along those lines. So I try to not worry so much about defining identity by way of what I've studied or the work that I've done. But that can be tricky. So, and it's tricky now because I've decided I'm moving away from the school stuff I've studied and from my original career path. Despite what labels you can apply to yourself or what labels people could apply to you, there are some through lines and sort of themes over the years that I've encountered. And they come in the form of some things, sort of high level kind of categories of things that I love. So those things are design and building. So, but what I mean by this is things like, I can even show you here, like this here. This was a design I did some time ago. I've shown little bits of this on a stream before, but this is, by the way, the laser tube cutter that I learned to use. So this is a little iPad stand I designed and built, and I used it for a while. To be totally honest, I don't use it now anymore. It's dismantled, but the design and the build process was just thoroughly enjoyable to me. When I was a kid, and even now, I play with Lego because I find it quite enjoyable to put the pieces together and get something from, you know, little simple pieces. You can make a complex looking, awesome looking structure. So that's what I mean by building and designing. I usually mean physical products, furniture. In undergrad, I did a bit of structural design for some prototype stuff that went into MRI machines. It just really feels great to sit and think about 3D physical space, materials, and how you can combine them. I really think every human can be empowered to do wonderful things with their mind, with their bodies, and I try to encourage that as much as possible. I try to run this stream in such a way to prove that you don't have to be some super genius to use a computer to do awesome and fun programming things. I'm not particularly skilled at some of the advanced programming things, but I can do it. And I love encouraging and empowering everyone to similarly pursue effortful skill building to also be able to do things that they want to do. I also think that creativity, focused in on some real big things, on real global challenges, is actually one of our best ways forward as a collective group of humans trying to make our way in the wild world that we find ourselves in. And I think this is certainly not the only way to solve problems. In fact, if we were to only try and solve problems by building tools and using technology, I don't think we would achieve holistically useful results. I think human systems and societies are complex enough that we need kind of a... Now, I can give a sort of benign example. This is... I had shown this earlier. This was all written in code and produces a nice visual result. And so you can imagine if you're a programmer, you could come to this document and read through and get the exact measurements and things like that. But if you're a manager and all you want to do is show to someone what the final product would look like, you can go to the same document, scroll down, and play around with this and see it, right? So you can, there's this multi-method of communicating the same kinds of ideas. I think that's very powerful. So some simple examples. This is a more modern example. This is a design I had worked on. And this is actually, this code can actually be written in. Now, written in and updated. So I can go like this, and the document will recalculate the dimensions here. So this is another additional layer of usability, where the same visual and programmatic information is communicated along with prose, right? So you could call it philosophical information, sort of motivation from the designer or designers, visual information for people who need to build it or want to showcase it, and programmatic information for people who want to understand the structure behind this. So that is the kind of programmatic CAD that I want to build out into a state where it can be useful for individuals in an open source manner and for companies in a licensed and usability in a useful manner for small to medium to, who knows, eventually large businesses. Oh, it's dropped like the demo. Of course. And I go over to this site here and refresh this. That particular image is extracted, and I put a silly little SVG animation on it. But it extracts the line work from this. It removes the all the other elements of it. I want to be very clear, this is not, like, the artwork is not mine, just the program is, right? So this Drawfew channel is exactly what you should be looking for. If you're interested in this, they're like a comedy kind of art channel. I think they're quite awesome. But it works. It's probably not perfect, but it works, I think, reasonably well. I don't know. I haven't tried this, so let me try this this one here for a minute. The idea is that you could run this over, so I have no idea if this will look correct. It might chop the image. Oh, that actually works better. 500, 500. This should work. Yeah. So it doesn't look as cool as I want. Also, it is upside down. That's obviously an issue. Promising. Pretty promising. Okay, that's more what I need to see. Not bad. And paste that here. Zoop. What? I thought I had it right. I thought I had it on lock. But I am evidently wrong. So I want to take... What did I do wrong? I'm just copying the wrong points by accident. There we go. That's what I'm looking for. Wire. This is welding wire from the shop. They have automatic feed MIG welders, and I took a little bit of wire from one of the machines, and I used it to experiment with tessellated, loosely speaking, shapes where, you know, the base unit is these triangles. So I did two things. The first thing I did was take a wire, cut it to length, and then bend it here like this, and then here around again, and then a third bend like that, and I bent them in such a way that this point and this point ended exactly next to each other. So what it looked like at the end was something kind of like this. So there's the gap here, and there's the bend radius left on each of those corners there. Additionally, so I actually have a sample of that I can show, and I discovered building it. Give me 1 second to grab it. This I was holding in front of the mic like you would be able to hear it or something. That's ridiculous. So this was my attempt at bending the wire into these little triangles, and then this is solder, and trying to just solder them together. And you can see, here in particular, there's significant gaps here, and this little experiment just it felt to me like this wasn't the right way to go with assembling these triangles, because controlling the bend was quite difficult. Getting the appropriate length of the edge of a triangle was tough, and holding it in place to connect it was all a bit of a challenge. So this is idea 1. And idea 2 is extremely simple. You just cut wires to specific lengths like that, and then connect them here, and here with solder joints, and then you can build a structure one joint at a time. So I made this thing. I'm pretty proud of this. It's the first time I've ever done anything like this. It's all solder joints and straight cuts of wire. There's no bent or angled pieces on this at all. I mean, aside from the natural curve in some of the wire. So I managed to get this done. This is a trident from the game Hades. I've been playing that game a lot, and just figured it'd be kind of cool to pull a symbol from it and design this. So this was how I managed to design this thing. I ran it. I used the Delaunay triangulation. I drew it on my iPad. I simplified the shape, and then I did a Delaunay triangulation and marked before I did a triangulation, I made a randomized grid over the bounding box and filtered for any points that were inside the shape, and then I triangulated it. And so the triangulation algorithm, as you can see, doesn't cut the triangles away because I haven't implemented that, but I was able to use this fine, transfer it to a piece of paper, and then put that on I used cardboard, and I used that to place all of these and solder them all together. So that was a little bit of the work there. Oop.